Hi everyone, good day to you. Let me continue for the vector topic. Today I'm going to cover with you surface integral, and I forgot to ask you, how are you? I hope that all of you are doing good, and we are nearly going to end this vector chapter. The topic today is a kind of last topic because this is the last topic anyway, so one of the very challenging topic as well. And I'm going to cover today surface integral, and surface integral is one of the very advanced topic in vector, and this will be the ending chapter also. And this surface integral, it has many component inside. Later you can see all the learning whatever topic that we learned before, it will be integrated in this topic. Therefore you might find it, this topic is an integration of whatever that you learned before. Here we're going to incorporate everything, the curl, divergent, and gradient, all this component including triple integral and double, everything will come into this topic, and we're going to combine all this topic into one single topic called surface integral. And surface integral, therefore please, this topic required very intensive understanding, therefore please be attentive. And as I promised that I will able to release all my notes as well, but I'm trying to instead I'm trying to capture this in any tools. I prefer to scan this, but at the moment I don't have any scanners with me, but I'll try to scan every notes of mine and put up in the upload it in the e-learning. Okay, I will do it as soon as possible. I'm trying, because I'm trying to compile it everything together and just put it together. But please, what I want you all to do is just copy. When you start copying my work, then you will learn many things. And I notice many of you seriously following the notes, and I notice many of you capture the notes of yours and send it to me. And when you discuss certain things, then I really amazed with your work, and it's a very good way of doing things. And instead depending on my notes again, and once I send these notes, definitely you start reading again. You never copy again these notes. And it's not copying, it's a matter of you follow the logics behind this topic. That is most important things. Okay, without further ado, because this is I'm having a lot of limitation. One of the things is battery, see, and therefore okay, today I will cover the first surface integral model, and I will go step by step like ABCD, and please try to understand every single step. Is everything play the important role, otherwise it's very difficult for you to understand this logics. I know you can study many books, but for sure I may say this is one of the very challenging topic, and it required very intensive understanding, and it's required a lot of attentive work, hard work. Therefore please pay some attention. Okay, let me introduce to you one small formula. I will later explain to you what is the surface integral while I'll proceed, but first let me introduce or define certain things before I slowly move into the problem. Okay, first of all, you're going to see ds, okay, and n. I'm going to introduce to you part by part. You can see this is one of the big S. I'm going to introduce this big S because I follow the books. There is another S, which is, we call it small s. My S is always look same, but I try to make it that the ds is a big and ds here is a small, and this is what we call as surface area. I will call it this as a surface area. Please follow the definition carefully. Okay, slowly I will introduce to you many important messages inside. One of the things here is a normal unit vector. Okay, normal unit vector. I hope that you can see. I'm not sure whether it's too small to you. Hope that you can see what I'm writing here. Okay, with this, can I make it a little bit bigger? Okay, I hope that you can see the things better. Okay, now inside here, this is what I'm going to define. Okay, this is not the formula anyway. It's a part of formula that I'm going to elaborate on this. Okay, okay. Now, earlier we learned something about. Okay, there is a lot of revision to be done here. Okay, we learned something. Okay, that there is a theta and a vector and b vector, and this is a combination of this. And as you know, between this a and b, and you can get when you start times with that is a product rule of the vector, and you can see this is what you will get it. Okay, based on this knowledge, I'm going to combine certain logics. Okay, I'm going to apply some simple logics whereby you can see I'm trying to introduce to you step by step again, as I say. Okay, let's say there is a small surface. Imagine this surface is one of the smallest surface that you can see, and this is idx. I call it, this is from idx, and let it be, this is idy. And imagine this is a unit vector, and the smallest length of dy and dx, and there is a one direct line here, you can see, which is a product rule here, which is, I call it as n k. Usually we will call it, this is a z. I hope that you can understand this, because you imagine this as a coordinate system, which is the coordinate system is x, y, z. Okay, similarly we use this. When we start doing this, imagine this is a smooth surface. Every definition is important, as I say. This is a smooth surface. Okay, I put it this as a smooth surface, and now okay, with this can I see, I'm going to compare the similar work here. You see, when you compare, you will get it. One I product with the dx, okay, times with the j, it's all coordinate, this is a unit vector, and dy, you will get, okay, what is the product of I and j, okay, times, you will get it k. Can you understand this or not? This is very important. Okay, this is k, and of course this is a length. Okay, we can use as usual the times. Okay, it's not vector anyway, this is a unit. Okay, you can treat this as a kind of constant. Okay, therefore we times these two constant. Okay, but this is a vector. That's a very important things. Okay, with this, now you can see this dx dy, we can call it that as a dA, but still this is a k unit. Okay, when I times with I and j, I will get n. Can you see this? Something similar to here. This is a normal vector where I'm going to equate with the k. Okay, therefore, and we're going to refer first. I'm introducing simple concept here. First, we're going to explore step by step. Later I combine, slowly I expand these logics. Okay, I'm going to expand these logics. Then only I'll show you the whole integration of surface integral. Okay, we will try to understand what is n now. Okay, now at least you got it, the logic. So n is a normal vector on the surface which is normal to this. Okay, later I'll show you practical application of this. Okay, you can imagine this is a kind of surface, for example. Okay, imagine there is a kind of surface, but the surface reacting. Okay, the surface is reacting straight away. Okay, normal. Okay, orthogonal to this surface. Okay, that's what the message is. Okay, now in this case, okay, now if I call it what is n anyway, okay, and n is a, we know this is a normal unit vector. Okay, is it too small for you? I'm not sure whether you can this is a normal, okay, normal unit vector. There are two compositions inside here that which we're going to go and explore into very detail. One is we call it as a smooth, okay, smooth surface, smooth sometimes the pen too, smooth surface. Okay, smooth surface. Another one is not smooth surface. Okay, not a smooth surface. Okay, for your understanding, just I will sketch for you certain what I mean by smooth surface, what I mean by not smooth surface. Okay, how do we identify the smooth surface? Okay, how do we identify the smooth surface? The smooth surface can be defined as something when you put it the normal, you know, check the normal here, you can see the normal is never changed. The angle is not exist here, it's all 90 degree. Okay, it's all 90 degree, exactly 90 degree. That means the surface is smooth, very plain. Okay, no changes, no curve or no bending or something like that. Okay, it's a straight smooth. Okay, from here we can identify, right? Okay, we know this is a smooth surface. But what is a not smooth surface? Smooth surface is looks smooth, but I try to make it a little bit like curvy kind of things, at least to show to you this is not a smooth. Okay, when you see this is not smooth, you can see the normal is something very what do you call, the angle will change. The angle will change. For example, most probably here, when you see, okay, wow, this is something unusual. It's like a very curvy. It's here is a curvy. Okay. Therefore, from here, the normal vector indicate to us whether the smoothness of the surface. Okay. We are identifying the smoothness of the surface based on the normal unit vector. Okay. Therefore, at least now you got the logics. We're going to analyze, we're going to explore this, what is smooth surface in detail later, not smooth surface. Okay. Okay, so far I hope that you got it. I will use the same, you know, paper. It's easier for you to see what I'm trying to say. Okay, what I mean by smooth surface here. Okay, smooth surface. Okay, first I start with the smooth surface and how do we define the smooth surface. Smooth. Okay, smooth surface. Okay, in a scenario, there are three scenarios we can define. Okay, for example, there are case. First, let me introduce to you y and x. If in the Cartesian coordinate system, the smooth surface, let's say this is the case. Okay, this is the case, and you know this is a surface, but let's say we define the surface smoothness based on the normal unit vector. Let's say the normal unit vector is pointing towards below. Okay, pointing to below. Therefore, the end is a, this is a z, right? It's a opposite to that, therefore we call it, this is a, the unit vector will be negative k. Okay, okay, it's a simple, right? Can you understand that? Okay, now number 2, I'll give you some scenario, further scenario. You can see how I defining this. Okay, let's say I'm throwing another one. This is x, this is z and y. Purposely I'm changing the coordinate system model, because always don't refer to this one, okay? Because you need to refer according to the x, your coordinates identity, okay? That's a very important. You can see, okay, simply I can change, because I'm reminding to you, because it's not always you can see the orthogonal coordinates will be z, not necessary, okay? Therefore, in this particular case, the surface, can you guess this? Okay, let's say I need to show the what you call the normal. Okay, the normal is very important. Normal unit is pointing outside here. Okay, can you guess what is the n here? Okay, the n here, okay, normal unit vector is equivalent to negative I. Can you see that? Because it's x is going opposite to the x here, therefore the surface is very obvious. Surface is directed towards negative I. Okay, now you can see the next one, the next 3, the third one. This one I just plot again. Please always check the coordinate. Cartesian coordinates play the important role here. Okay, we decide based on the normal and a Cartesian these things. Okay, if this is a scenario, then I just purposely, you must refer to normal. Don't ask why is going down and up first. Later I'll explain to you what is this. Okay, when you apply this, then you will know what I'm trying to pointing out here. Okay, in this case, what is normal? Okay, can you guess this as well? Please, can. Okay, because you see, we are still referring to the x, right? Same direction to the x, therefore it's a I. Okay, so far you get it this. Okay, I can give you many examples similar to this, but no point. I'm spending more time which is that which you can understand the things better, right? Easy. This is a slightly easy. Okay, now we're going to go and explore what is non-smooth. Again, you look at this. We already have seen smooth surface can identify straight away. It's no problem because it's just negative I, j, k or any one of this. What about this? Okay, how to identify this non-smooth? Okay, okay, with this one, okay, with this one, we can see I'm going very systematically here. Therefore, this notes is very what I call is well tested of mind. Okay, therefore I did these notes very systematically. Hope that you can follow the notes properly. Okay, in this case, not smooth surface, what I define by that, okay, let's say there is a surface, okay, is something like that. Okay, and okay, it's look like that. Can you guess anything? Of course, you know the surface is not a smooth. Okay, okay, first of all, you need to know there is a one function called xyz, which based on this xyz created this surface. Okay, that's what I want you to understand. Therefore, this is, we call it in another term, surface creator. Some student really confused about this. Creator, okay, creator. Okay, this surface creator, now we're going to identify the surface creator, how the surface creator really works in this scenario. It means, let's say, I'm trying to show you there is a various type of surfaces. The normal, okay, is something like this. It's not a straight anyway. Okay. The first question to ask. Okay, sir. This is not a smooth anyway. Okay, not a smooth surface. Okay, if this is not a smooth surface, how do we find out the end? Okay, it's a many combination of this, right? Many combination of that. Okay, earlier we studied everything here. When I touch here, you see this point, every single point is a straight. It's not as this thing. It's every single point is a straight equivalent to the K. When I say it's a smooth surface, any normal unit vector at any point of that surface will be same. That's what I am trying to say. Smooth, for the smooth surface, anywhere you touch, it will be like this. Okay, it will be similar to this. Okay, same. But not smooth surface, no. It's a combination of various, okay, angle. Therefore, in this case, same. Okay, what is the best to calculate this? Here, in order to calculate, we need to use normal vector for the gradient f and unit of the gradient. Now first time you started seeing again the gradient is come back again. You see, it's leaving, his life is coming back again. Then now we need to, first time you are seeing what is this. Okay, we are seeing the gradient of f and unit of the f. Okay, now you can see what I mean by the gradient here. Okay, gradient means now you know the different angle. Okay, different angle of this is for the definition of the physics, actual physics. Okay, but some student did ask me, sir, can this f can be a vector? Okay, for the gradient, okay, for the del vector can, or is it a scalar? Okay, the f. Okay, remember the f here that we are referring in this particular case is a surface creator. Okay, surface creator. Mathematics can allow you, okay, can allow you to go for any combination. Okay, but in this particular smooth surface and not smooth surface definition, this must be surface creator. But the first question, is it a vector? Is it vector? No, right? It's not a vector. Okay, it's not a vector, it's a scalar. Okay, now in this particular scale, we combine this, then only it's become a vector. You can see as a del f, del x to the I, okay, del f, del j, del y to the j, and del f, del z to the k. Okay, divide, okay, the combination of all these things, which is del f, del x power 2, okay, plus del f, del y, del f, del z power 2. Okay, that's a unit vector. Okay, so far you got the definition. Okay, systematically I hope that you can understand one by one. Okay, now with that, now we go back to the second definition. Now you see in the ds, we started with this, right? Okay, ds. I already defined to you what is n now. Okay, now you can see, oh, n can be a smooth or not smooth. Okay, now we're going to analyze this as small s, and a combination of this later become a ds big. Okay, now we're going to analyze the s here, the small ds. The small ds will be defined as, small ds is a surface area. Okay, surface area. Okay, there are two type of area, surface area we're going to analyze. Okay, this is really confusing, you know, when you refer books. Student, I can for sure you refer many books also. Sometimes you tend to confuse because the usage of symbols is a little bit confusing. Okay, sometimes they use big as, you know, they very difficult to sometimes they confuse. Why suddenly DS big, or is it a small then suddenly N appear? Okay, now if I explain anything, you won't be able to see, but slowly you follow first. Okay, I'm trying to follow the book convention. Okay, because convention is very important, because you can read the book. Okay, when you read the book, you can understand. That's why I'm saying this is very important. Okay, DS is a small s here. When S, the DS will refer to again. Okay, I'm going to put it that to the 2. Okay, 1, we call it this as a actual. Okay, actual surface. Another one, we call it that as a not actual surface. This is a little bit confusing. So I can understand actual surface. What is not actual surface? This is not actual surface. I call it this as a shadow. Okay, we call it that as a shadow. Okay, wow, if this is a real face-to-face class, I can demonstrate to you many things inside here. Okay, can you see this shadow here? In my paper itself, you can see the shadow, right? Okay, can you guess what is there on the top of this? Cannot, right? But you can say, oh, I can see something here, the shadow here. Can you see this shadow? Okay, it's a something kind of line going on. Okay, that means you can you guess these objects or not? Okay, what is the object on the top? Okay, there is a shadow, but for sure you can tell, right? Okay, but when I show my hand, at least where is my hand here? Here my hand is coming, but the shadow, I wanted to show you that shadow. Okay, but doesn't matter. Okay, but I, at least you know there is a shadow. We can use a shadow also to calculate. How? Is there any possibility? Last time we used to do this kind of calculations. Okay, I'll give you, usually I'll ask the students to do one kind of activities there. Okay, even though this is an online class, I would like to discuss the same with you. Can you measure, for example, can you measure coconut tree? Okay, the height of coconut tree. How do you do that? Okay, I will give you, for example, 1 meter ruler. That's it. Okay, how do you do that? Can you measure that? What is the way to do that? Is there any method? Okay, okay, think for a while. This is actually physics question. Okay, physics. Because I still remember when I was in Form 4. Okay, this question was the physics question of my exam, if I'm not wrong. They did ask, okay, how do you measure, okay, coconut tree if I give you 1 meter ruler? Okay, then how do you do that? Okay, this is a Form 4 question, you know. How do you answer that? How do you measure height of in a coconut tree? Don't say you're going to climb. Okay, if you are you expert of this? You can climb, climb up the tree and use the the ruler to measure the height of coconut tree. Okay, it's not practical, right? Okay, it does not make any sense to you. Okay, without wasting many, Okay, there is a coconut tree, for example. Okay, there is a coconut tree. Okay, all of you know my drawing is superb good. Okay, okay, let's say this is a coconut tree. Okay, and assume the coconut tree height is D. Okay, D. Okay, can you see that? Okay, I'll try to put it this way. Okay, one of the way to measure the coconut tree, the height of coconut tree is, okay, you may say, by now you started guessing the logics and say, sir, I got it, some idea. Okay, you're fine. I know. Almost all of you started saying shadow. Okay, good. Okay, let's say you started seeing the coconut tree shadow. Okay, Okay, then how to do that? Okay, let's say this is the shadow you are seeing. The sun is there. Okay, sun, you cannot be here, always it must be here, somewhere here. Okay, now you can see the shadow. Okay, how to measure then? How to measure? Okay, you go and measure. Then how do you know? How do you know the height? Is there any way? See, you will have a 1 meter ruler. Okay, then you say, okay, I can measure using a 1 meter ruler. Practical, yes. Okay, you can start from here. You measure. Okay, you know 1 meter. You know how to use this already. Okay, superb, good. Okay, then what is next? How to find out the D? Okay, I call it this as the shadow here. Okay, the shadow here, I call it as a C. Okay, the shadow here, I call it as a C. Then how to find the D? Is there any way? Got it? Any ideas? No idea. Tada. Okay. You must use yours. Okay. Your actual height, suppose lah. Kalau if you don't know, then nothing to comment lah. Okay, you should know your actual height. Okay, you know your actual height is something called A. Okay, then you are trying to see your shadow. Okay, your shadow here. Okay, then use ruler. Then you can see that. Okay, ruler, the thing, you can use a ruler to measure the height of the shadow called B. Okay, this is a shadow height. Okay, shadow height. Okay, can I calculate now? Can. How? How do you do that? Okay, you can. Okay, A divide with the B. Okay, the shadow A divide with the B shadow is equivalent to D divide with the C. Can you get that? Okay, now can I get the D? Oh, for sure, because this is known, and you can find out the D. Okay, wow. That means you can calculate, or you can use shadow to calculate the height of Twin Tower. For example, I'm saying, okay, this is a simple way to measure the height, or you can use the shadow to calculate certain things. Okay, now at least you find it. The shadow is not a joke. Shadow also is very much useful, and please don't underestimate the shadow. Shadow played a very important role in ancient science. Okay, they use a lot of things to calculate. Even they use time. They got the whole science of time, basically the calendar system that at the moment that we have, based on shadow. Okay, amazingly they use this shadow to calculate the movement of sun. They managed to get the day clock through shadow, and not only the day, they managed to calculate the whole years based on the shadow. Amazing. Okay, it's really amazing. I think their technology is very simple. They use one simple tool only one stick. They use one stick to calculate the whole thing. Is it quite amazing, right? Okay, they can use one stick to calculate the whole years, these things using shadow. That means a shadow is not a simple thing to say. Okay, now I'm going to introduce to you actual. Okay, I use this side here. It's not a saving paper, but it's easier for me to go back here, up and down here. Okay, now actual. When I call it actual surface, okay, I call it actual surface. There are three things that we're going to use. One, we're going to use Cartesian. Okay, coordinate model. We're going to use a Cartesian. Okay, number two, we're going to use cylindrical or cylinder or cylindrical coordinate system. Actually, what we are saying is a coordinate system. Here cylindrical coordinate system, and the same thing is a spherical. Wow, this is all we're going to combine. I already told you before, we're going to combine all the things that you learned before. Okay, therefore the actual surface is it can be a Cartesian coordinate system, cylindrical coordinate system, spherical system. Okay, let me introduce to you one by one. Okay, here also I'm introducing to you step by step whatever you already learned before. Okay, the first portion, okay, we call it that as a Cartesian. Okay, Cartesian. Okay, actual. Okay, later I'll teach you how to handle the shadow. Okay, Cartesian, for everything it has a shadow also. Okay, Cartesian, actual. Okay, in this case, okay, now you can see the Cartesian here. For example, we learned before dx dy. Okay, therefore the ds surface can be defined as ds small as a, remember, ds, this is the purpose I use the same paper. See, ds, since it's an actual surface, ds is an actual surface, I can use the another convention called dA, since it's actual. Okay, ds, now you know why they don't use exactly straight away area. They didn't use a area. Okay, they didn't use a area straight away. No, actually ds play the two roles. Surface, the surface ds stand for surface. Surface play the two role here. One is actual, one more is not actual surface, right? Therefore this is a, since it's actual area, okay, we can write this as a dy dx or dx dy. Okay, this is you already known to you. Okay, what about the cylindrical? Okay, for cylindrical, can I think the space is not good here because it's slightly, okay, but can I finish that? Oh, a lot of things to draw, but okay, I use a different paper here. Okay, now you know this is actual surface. Now I go for the cylindrical. Okay, the second one is when I start moving the camera, okay, is zooming again. Okay, hopefully no changes in the paper then. Okay, cylindrical actual or cylinder actual. I just say what is cylinder actual. Cylinder actual, cylindrical surface, actually I'm trying to say cylindrical surface but actual. Okay, when you refer to this, okay, cylindrical I already defined to you, but now we're going to focus step by step. This one also you can see I introduce a new formula to you. Okay, d theta, and we know this is a r, okay, radius. Okay, what is this? Circumference. The circumference can be defined as r d theta, no problem. So far we already learned that. Okay, now if I pulled up bit here, okay, this one, this surface, okay, this is a surface of cylindrical, right? This is dz. Okay, now you see, now the question is, what is the surface? How do we find out this surface? Can you see this surface only? We are not calculating the volume. Remember, we are not calculating the volume. We are just calculating the surface. Surface means here, remember, I can pull up bit. This is surface. Surface, what I am trying to say here, the surface of this cylinder here, surface, all this. Okay, I tear this surface here, cylinder, okay, here, then the cylinder become like this. Okay, can you agree with me? The surface, okay, here you can see two. Okay, if I cut it off using one scissors, let's say I cut it off this, you can get a two circle and one rectangle. right? Therefore, in order to calculate this surface here, okay, this one here, okay, this one is the circumferences, okay, ds. This is a ds. You can see this is a ds. Okay, I just write like that. Okay, this circumference here is defined as a, which is a r d theta. Can you see this? This is r d theta. Later you know this one to calculate, no problem. This one for you is not an issue. Okay, but for the moment I just introduced to you this part first. Okay, therefore there is a 2 combination for the ds here. Again, this is since it's an actual, I can introduce that as a s, and this will be r d theta dz. For what? For referring to this one. Okay, what about this? What about this? This is circle, right? Okay, circle, area, okay, as all of you know, area is what? Pi j, pi r square, right? That no problem, right?